Hi all, welcome back to our next video. In previous video, we have seen what is pod, replica set and deployment. If you did not watch this video, please go back and watch my previous video so that you will be able to better understand today's concept. In this video, we are going to see one more important Kubernetes object and that is nothing but a service. So, let's start. So, what is Kubernetes service? In previous video, we have seen a pod is nothing but an running instance of our application. So, if we want to balance the load of our application, we will increase or decrease this number of pods. And to make sure to have a specific number of pod of our application, replica set will play an important role. Now, every pod has their unique IP address. So, if we delete one pod, replica set will create another pod with another IP address. So in short, the number of pods will always get changed and the IP address will always keep on changing. So we cannot really use the IP address of the pod to expose our service to the external world. So we need someone who will provide abstraction to these pods and will help us to expose our application to the external world. And that is where one of the Kubernetes object come into the picture, and that is nothing but a service. When we expose our application via a service will take care of all the dynamic IP addresses of the pods and always provide a reliable interface to the external world or end users to access your application. And that is nothing but a service. Let's try to understand this service on cluster. Okay, and to understand this concept in better way, I just made few changes in my application. If I open this file, now as you can see here, if we want to access URI hello world, it should display the hello world along with the current host name of our application where our application is running. And to access the host name, we will just read this environment property hostname colon local where local will be the default value, right? So I just added this service and I'm accessing that service from our REST controller. That's it. And this is our main class. We do not have any other changes in our application. Fine. So once it is done, I will just come back to our command prompt. So I just build that application. Now its image is created. Now as you can see here, this is the new image which is created, this one. And then I just add the tag on this image with 1.0.3. And then I use command docker push to the new tag name and then push this tag to our docker registry. So now new image with version 1.0.3 is available on docker registry. Now let's come to our cluster now. Okay, and then connect to our Google Cloud account. You should be able to see the cluster which we have created in our previous videos. Now in our previous videos, we have seen how to create clusters and then how to play with the different Kubernetes objects. So if you did not really watch those videos, please go back and watch those videos. Otherwise, it will be difficult for you to understand what we are discussing today. On the right side, you can see activate Cloud Shell. Just click there. And as usual, I always like to open it in new window. Now my Cloud Shell is ready. And to connect to our cluster, what to do? Just come back and click on connect button, copy the command, come back to Cloud Shell and just paste it. Enter. Yes. Now you are connected to our Kubernetes cluster. Type command kubectl get pods. Now you can see the three pods are already created for our application which we deployed last time, right? Then just say kubectl get pods hyphen o void. Now you should be able to see the different IP address of these pods. Now see, these three different pods have their own IP address. Now what we will do, we will just try to delete one of the pod. So just type the command kubectl delete pod and just delete any one of the pod. Now this pod is deleted. We will type the command once again to see all the pods. Kubectl get pods -o white. And now you can see the another pod is created with a different IP address. See, this is the pod which we deleted, and this is the pod which is up by the replica set to make sure that three number of pods are always running. So even if we delete one pod, the replica set just bring up another pod with another IP address. See 10.12.0.11. And this is how every time replica set will make sure that desired number of pods will always keep on running. Now let's see what is the status of our replica set. Using command kubectl get replica set. You can also use res in place of replica set. -o white. Enter. Again my mistake, spelling mistake, replica set. Okay. Now as you can see here, there are three pods which are running for the newer replica set, and these pods are referring to the image with version 1.0.2. Now we will upgrade this application to the newer version, that is 1.0.3, which we have just pushed to our Docker registry. And how to do that? For that we just need to update the command, this one, kubectl set image deployment hello world rest API. This is the name of the deployment and this is the name of the container, and we will just say refer to 1.0.3. Enter. Say image updated, kubectl get pods. Now you can see the newer pods are coming up and the older pods are terminating. Okay, I will clear the console first and then check the status of our pods. Okay, there are three pods which are running. Let's check the status of our replica set. -o white. Again, spelling mistake for replica set. Yes, fine. Yes. Now you can see there is another replica set which is created. Three pods are running for this replica set, and these pods are referring to the newer version of our image, that is 1.0.3. Okay, and then now our application is ready. Our pods are running. New replica set is created for the newer version of our image, and now let's try to access our application. And how to do that? Come back to our cluster. Now click on services and ingress, and you can see the endpoints. Now just try to read this definition of services here. Services are set of pods with a network endpoints that can be used for a discovery and load balancing. Now, how it actually works, we are going to see it, but just try to understand that it provides a network endpoints that can be used for the discovery of load balancing. Now we had created number of pods here. You can see here are three pods are created and each pod has their own IP address. But to access our application, we will just use the endpoints which is provided by a service. Just click here. Okay, now you can see our application is up and healthy. Just type hello world. Now, as we have already seen that we have modified this URI to display the current host name of our application. Now, currently it is displaying WVCZ, and let's see what is it. What is it? Come back and see. This is the current. Yeah, this is the host name. It is displaying. Now, what is this? Now we access our application using the endpoint provided by the service. And then service will decide to which pod he has to redirect this request. This time he has redirect that request to this pod, right? Again, let's try to access it. Now you can see it, C92XJ. Come back to our cluster, and yes, second time he redirect that request to the another pod. So every time we are just accessing the endpoint URL which is provided by the service, right? And you can see every time service will decide to which pod he has to navigate that request. So this time he has navigated to VFC. Previously it was navigated to WPC, and before that it was navigated to this one. So service will decide how to balance the load of your application, and according to that he will decide which pod he has to select to serve your request. So what is the theory? We can always have a dynamic number of pods, and the IP address of these pods are always a dynamic. So we cannot access our application using the IP address of these pods, but we are exposing our application through an service. Now service is providing us an endpoint URL to access our application, and user don't have to worry about the dynamic behavior of this pod, and users will be able to access your application always with a single URL provided by this service. And this is how the service works. Now, a very important question. Who has created this service? Because we have not created this service using any command. So question is when this service gets created. So now as you can see here, this is the command which we use to create our deployment. Right? We use the command like kubectl create deployment. This is the deployment name, and this is the image name which we use to create this deployment. And then we expose this application using kubectl expose and giving the name of the deployment. And we use here the type is equal to load balancer. And this is when our service gets created. When we expose our application to the external world using this kubectl expose command, that time only this service gets created. Let's try to understand service on the UI side. Now you can see here, this is the service which is created. This is the endpoint URL which we refer to access our application, and it is using 3 pods, right? Just select this service, go inside, just scroll down. Yes, and now you can see here, this is the label of the service, and type is load balancer. Now as I mentioned here, this is the type when we expose our service. Type is load balancer. Okay, then come down. This is the external endpoints which we use to access our application. You can see, you can just cross check 35.202.101.146, right? This is the endpoint URL, and this is the load balancer which is created for our service. Okay, now let's try to type here load balancer. Just remember this name of the load balancer end with a 0006 load balancer. Yes, select load balancing. Yes, you can see this is the load balancer which gets created for our service, and we are not doing anything specific for this load balancing, but service will take care of it. Just see, select this load balancer, go inside, and you can again see the same details like this is the IP address, and these are 3 instances uh, which is used by the service to provide the load balancing. So this is all about this Kubernetes object service. Service is providing us an reliable URL, and using this URL, users can access your application without considering any complex things that are happening on your cluster. Thanks for watching this video. Please like it and subscribe it. See you in next video. Bye bye.